Alright guys, well here we go again. I apologize for the last video. I do a little bit better this time. So we're at section 5, pharmacology. And hold on a second. I really thought that I could do this with some music in the background, but it's just not going to happen. It's distracting to my pitiful little brain. Anyway, so we're back to this study. We left off, and they were talking about all the different analysis methods that they were using, and it got super fucking dry. So we kind of skimmed past all that shit, and we're going to take a fresh crack at this in Section 5, Pharmacology. And there's, I reviewed it already, and I think it's not too out of this world, like scientific-y and like overly written, but there are some definitions that we're definitely going to have to get first. I actually have 6 definitions here that we should probably lay down before we get into section 5. And I'll tell you right now, if you're interested in learning about harmala, beta carbolines, the health benefits of the squeezins of the Peganum harmala, which is just fucking fascinating to me, but to a lot of people it's going to be drier than a popcorn fart. So feel free to tune out right now if you want. But if you're willing to stick around for a minute and maybe learn something, then stay with me. So let's read this brief blurb on pharmacology, and then we'll get into some of our definitions. Pharmacology. Various traditional uses of plants from the genus Peganum have led scientists to investigate their pharmacological properties and to validate the potential uses of this genus as therapeutic remedies. During the past decades, the genus Peganum has been increasingly studied for its broad spectrum of physiological and pharmacologic properties. Several pharmacological activities and pleiotropic health benefits have been reported to be exhibited by extracts as well as single compound of some species from this genus, such as anti-AD, that's going to be Alzheimer's disease, and anti-PD, that's going to be anti-Parkinson's disease effects, antidepressant, anti-tumor, anti-diabetes, analgesic, anti-withdrawal syndrome, anti-hypertension, anticoagulant, antimicrobial, antioxidant, and anti-inflammatory, among other things. Refer to Table 3, and we're not going to go looking for the table. But yeah, so I mean that was kind of a recap of all the fucking antis that were listed in the first video that got to the point where I just had to fucking scroll past them. There's so many. I mean, it's kind of, I mean, anytime I hear of or see any kind of compound that claims to have, of course the compound's not making the claim, but there are claims made that it works against so much shit that generally I automatically write that shit off as snake oil, but there's a lot of reality going on here, and we're going to dig deeper into it. So like I said, if you're interested, stick with me. If not, then now's the time to fucking go pour a drink and turn on the TV. So section 5.1, cholinesterase inhibitory activity and anti-Alzheimer's disease effect. Okay, right here is where we're going to skip to some definitions, because we're just going to jump straight into where we're going to need them. And we're going to start with acetylcholine. And there's a whole lot to read here, but we're mostly concerned with what it does. So we'll go to functions. And Like many other biologically active cellular offense. Oops, wrong section. Sorry. Acetylcholine functions in both the central nervous system and the peripheral nervous system. In the CNS, cholinergic projections from the basal forebrain to the cerebral cortex and hippocampus support the cognitive functions of those target areas. In the PNS, acetylcholine activates muscles and is a major neurotransmitter in the autonomic nervous system. So basically, it's a signal transmitter, right? Let's see here. In the brain, acetylcholine functions as a neurotransmitter and as a neuromodulator. The brain contains a number of cholinergic areas, each with distinct functions. They play an important role in arousal, attention, memory, and motivation. So that's kind of a brief overview of the Wikipedia page on it. Again, we'll go to the very first sentence of what they should have as the definition. Acetylcholine is an organic chemical that functions in the brain and body of many types of animals, including humans, as a neurotransmitter, a chemical released by nerve cells to send signals to other cells. Okay, so we have a pretty good idea of what acetylcholine is and what it does now. Now let's take a look at acetylcholinesterase. Acetylcholinesterase, also known as ACHE or acetyl hydrolase, is the primary cholinesterase in the body. It's an enzyme that catalyzes the breakdown of acetylcholine and of some other choline esters that function as neurotransmitters. So acetylcholinesterase basically is the shit that breaks down acetylcholine. Acetylcholinesterase is found at mainly neuromuscular junctions and in chemical synapses of the cholinergic type, where its activity serves to terminate synaptic transmission. It belongs to carboxylesterase family of enzymes. It is the primary target of inhibition by organophosphorus compounds such as nerve agents and pesticides. Let's take a look at biological function. During neurotransmission, acetylcholine is released from the presynaptic neuron into the synaptic cleft and binds to acetylcholine receptors on the postsynaptic membrane, relaying the signal from the nerve. Acetylcholinesterase, also located on the postsynaptic membrane, terminates the signal transmission by hydrolyzing acetylcholine. The liberated choline is taken up again by the presynaptic neuron, and the acetylcholine is synthesized by combining with acetyl-CoA through the action of choline acetyltransferase. Well, you're bullshitting. And a cholinomimetic drug disrupts this process by acting as a cholinergic neurotransmitter that is impervious to acetylcholinesterase's lysing action, which is really more than we needed to know. But basically, acetylcholine is the nerve signal transmitter, and acetylcholinesterase is the gizmo what stops that transmission from happening. Okay. We're going to look at beta-carbolines just because we need to. If we're going to talk about Peganum harmala or rue or harmala compounds, what I laughingly call harmaloids, then we need to know a little bit about beta-carbolines, but it's hard to just learn a little bit about beta-carbolines. So can I pull anything worth fucking reading out of here? Beta-carboline, also known as norharmane, is a nitrogen-containing heterocycle. It is also the prototype of a class of compounds known as beta-carbolines. Oh, Jesus, that fucking really doesn't tell us much of anything at all. Take a peek at the pharmacology. Oh, God. Well, that's what this whole study's about, so fuck it. Essentially, all we need to know at this point is that beta-carbolines is the name of the class of compounds that that Harmala and the Harmala compounds are in. So let's take a look at quinoline alkaloids. And thanks for bearing with me so far. I know that this is probably just making you want to pull your fucking hair out, but fortunately for me, I don't have any hair. So there is no quinoline alkaloid page on Wikipedia. That is interesting. But there is quinoline. Yeah. Again, they really don't tell us what it is other than that it's a heterocyclic aromatic organic compound. But what we can pull out of it here is that a prominent example is quinine, an alkaloid found in plants. So, fuck me. I'm glad I went to all the trouble of writing down shit that we need to fucking know. All right. So, in this study, throughout this study, you'll see references to something called an IC50, and that's going to be inhibition concentration, and the 50 is for 50% of the amount that has been clinically shown to inhibit whatever action we're talking about. Um, generally, receptor uptake is what we're talking about, or inhibition of monoamine oxidase. And another one that may come up in the study is SI, which is, I'm pretty sure, selectivity index, which is synonymous with therapeutic index, which is basically the amount of a compound that's been clinically shown to have an effect, for whatever that's worth. Okay, now that we've gone through that, we'll get into the rest of the study here. Using a TLC fingerprint that's oh my God, thin layer chromatography. Thank you. Fuck. Using a TLC fingerprint combined with bioautographic technique, the acetylcholinesterase inhibitive activity of compounds from the ethanol or methanol extract from seeds of a few different varieties of Harmala, of Peganum, were investigated, and the results suggested that harmine, harmaline, and harmol displayed similar acetylcholinesterase inhibition compared to galantamine, which is what they consider a control chemical, something that is known to inhibit acetylcholinesterase. Now, when they're talking about inhibiting acetylcholinesterase, they mean inhibiting the process by which acetylcholine is broken down. So the more acetylcholinesterase inhibition there is, the more acetylcholine you're going to have swimming around, right? So harmane was the most potent selective acetylcholinesterase inhibitor with an IC50 of 7.11 to 2 micromoles, give or take. And I'm looking at this right here, micromoles. I'm assuming that's micromoles because generally in chemistry the big M is mole, and this is your micro symbol. But I just really don't know. I wish that this was expressed in milligrams per kilogram of body weight or something like that. But it looks like this may not be from an in vivo trials. It may be from a test tube. I don't know. We'll move along though. The upshot is that harmane will inhibit the shit out of some acetylcholinesterase. Vasacine was the most potent butyrylcholinesterase inhibitor with feature of dual acetylcholinesterase and butyrylcholinesterase inhibitory activity with an IC50 of more shit that I don't have a fucking firm handle on. So, and it's butyrylcholinesterase, which we didn't bother looking up the definition of that in Wikipedia on account of it's a synthetic chemical that excuse me, butyrylcholine is a synthetic chemical, but the butyrylcholinesterase is an endogenous chemical and or compound, whatever you want to call it. And I wasn't really sure about if there was any point to looking up a synthetic compound that apparently they're just using as a control here, like a known factor that they can compare against an unknown factor, which would have been the vasacine. Anyway, that's just me rambling. Anybody that is smarter than me, please fucking give me a little mental slap around and clue me in. Because I openly admit that I know very, very little of what I'm talking about right now. But I'm trying my hardest. And by analyzing, comparing the inhibitory concentration and the selectivity index of these chemicals, it indicated that beta-carboline alkaloids displayed more potent acetylcholinesterase inhibition than the quinoline alkaloids. The quinoline alkaloids they're referring to is the vasacine. And that was what we were hoping to get a breakdown of from Wikipedia, but they're thoroughly unhip, and I'm not going to be the guy to put it in there. So they talk a little bit about placements on the molecule. The substituent at the C7 position of the beta-carboline alkaloids and the C3 and C9 positions of the quinoline alkaloids played a critical role in acetylcholinease or butyrylcholinease inhibition. It's been reported that the trace compound, which was isolated from the seeds of Peganum harmala 2-aldehyde tetrahydroharmine, has a potential inhibitive effect on both acetylcholine and butyrylacetylcholinesterase at these rates, respectively. Deoxyvasacine and vasacine exhibited the strongest butyrylcholinesterase, which really I'm not sure what the upshot of that is or what that really means, other than both two kinds of compounds in Syrian rue extract seem to separately inhibit acetylcholinesterase, as well as this butyrylcholinesterase, which I don't really understand where they're going with that. So nothing new there. More about substituent groups cited at C4 and C9 for quinazolines were important to both the blah 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 Yang et al. 2015. Okay, this is something more understandable. Harmine at 20 milligrams per kilogram, administered by oral gavage for 2 weeks, could effectively enhance the spatial cognition of C57BL/6 mice impaired by intraperitoneal injection of scopolamine at 1 milligram per kilogram. All right, cool. So it's a study, and it's a Chinese study, so there's going to be they're going to be talking about the mice they used, and some of the mice unfortunately didn't make it, and that's kind of the way it goes. But what they're talking about here is they gave these mice an injection of scopolamine, which is a powerful dissociative that makes you really kind of unable to remember your own name at a certain point. And so they got them all goony on scopolamine, and then they dosed them with 20 milligrams per kilogram, right? So if you're 200 kilograms, then that was 2 milligrams, right? But I don't think there were any 200 milligram or kilogram rats or mice or whatever the fuck in this study. So anyway, so they gave that shit to him for 2 weeks, and it enhanced the spatial cognition despite the scopolamine in their system. Meanwhile, long-term consumption of harmine for 10 weeks also slightly benefited the impaired memory of APP/PS1 mice. And you can look up these reference numbers for these mice. They're actually genetic strains of mice that are bred for different types of testing, I think. Don't quote me on that, but you can certainly research me on that. Furthermore, harmine could pass through the blood-brain barrier, penetrate into the brain parenchyma shortly, and modulate the expression of EGR1, C-Jun, and C-Phos after oral administration. I don't know what those are. Molecular docking assay disclosed that harmine molecule could directly dock into the catalytic site of acetylcholinesterase, which was partially confirmed by its in vivo inhibitory activity on esterase. Harmine could ameliorate impaired memory by enhancement of cholinergic neurotransmission via inhibiting the activity of acetylcholinesterase. Harmine was a significant enhancer of short-term working and recent memory, and it did not affect spatial reference memory at doses of 1 milligram or 5 milligram per day, and high doses of harmine produce clear but transient motor side effects, impacting ability to meet procedural requirements of testing. Generally speaking, the potent inhibition of acetylcholinesterase and butyrylcholinesterase suggests that these alkaloids may be used as potential candidates for treatment of Alzheimer's disease. Wow, that last part was kind of a trip, and we're sort of going to sum up what's going on here. Is basically that harmine and harmala in general helps the memory, and and at high doses produces clear but transient motor side effects. In other words, it'll make you walk funny if you take too much, but that'll go away after a while. And it's the action on these cholinesterases, the acetylcholinesterase and the butyrylcholinesterase, and that's apparently beneficial in Alzheimer's disease, because apparently what's happening is Alzheimer's patients are very short in acetylcholine, and I think the acetylcholine that they do produce gets like whacked out really quickly by the acetylcholinesterase and the butyrylcholinesterase. This stuff helps with Alzheimer's disease, which is like a serious fucking deal. I'm a candidate myself for Alzheimer's disease, as well as having had far too many traumatic brain injuries. So that's a major reason I'm interested in this. So section 5.2, monoamine oxidase, inhibitory activity and antidepressant effect. If you're still here, thank you so much for fucking tolerating this. I'm not sure how long I've been doing this, but I'm going to keep going until like 5.6, I think. So just bear with me. Unless you guys think I should, fuck, this video is probably already too long as it is. People fucking bailing out. All right, I'll tell you what. I'm going to go ahead and kill this and post this video, and then I'll do section 5.2 separately. All right, rock and roll. Rock and roll. I'm just going to do it the easy way.